birds usually don't have comm signals coming off of them. So if you get a radar hit, and then you also have spectrum sensing saying, hey, there's communications coming off of here, it's much more likelihood that that's a drone versus a bird.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello everyone, this is Randy Goers and welcome to this special InterDrone segment of the Drone Radio Show podcast. I spent 4 days at InterDrone 2016 and met up with some amazing people doing amazing things with drone technology. I prepared a series of short podcasts so you can hear the latest product announcements, advances in technology, and trends that will interest you. In this segment, we'll hear from Craig Marcinkowski, Director of Strategy and Business Development at Gryphon Sensors. Gryphon Sensors develops sensor systems that detect, track, and identify small unmanned UAS. I sat down with Craig at InterDrone to learn about the company's efforts in airspace integration and drone detection. Let's take a listen.
Hi, thanks Randy. Craig Marcinkowski with Gryphon Sensors. I'm the Director of Strategy and Business Development here.
Can you tell us what Gryphon Sensors does?
Sure. We're a spin-off from SRC, was our parent company, and they're a not-for-profit R&D defense company that's been around for 60 years. They've been really leaders in radar and electronic warfare for the U.S. military. They've also been leaders in drone, counter-UAS drone work, if you will, for the U.S. government, and SRC's been helping enable the military to integrate their drones into the national airspace. They've been working with the Army on their ground-based sense and avoid program using radar to detect non-cooperatives in the airspace and basically clear them from a see and avoid requirement with the FAA so they can fly without chase planes. We formed Gryphon Sensors 2 years ago to address the commercial markets for the same areas, drone security and also UAS integration. We're doing a lot of work with NASA on their UTM initiative, and we're using our own new commercial sensors, radars and others to look in the airspace. We're really good at detecting low, slow-flying objects, which are traditionally very challenging radar targets, and seeing those types of non-cooperatives. The work we're doing with NASA is to help enable beyond visual line of sight flight. So similar to what we're doing with the Army, but now on the commercial side, whether it's Amazon or all those other people who want to get into the airspace and fly beyond visual line of sight, we can see non-cooperatives that are out there in the airspace and help validate that your space is clear, or if you need to land or do a sense and avoid maneuver around non-cooperatives that are out there.
Can you explain how you're able to see something as small as a drone and how far out can you see that?
Absolutely, great question. So the systems that we're designing at Gryphon right now, one of the nice things, we're designing everything from the ground up. Every design trait is revolving around the small UAS. A lot of the systems out there right now are repurposed military systems where you have to make some trades, and they're capable, but they're not necessarily designed specifically for this threat set. What we're doing with the ground radar, the R1400, which is our newest radar coming out at Gryphon Sensors, it's a small, lightweight, man-portable system. It can detect a DJI Phantom out to 10 kilometers and general aviation aircraft out to about 25 kilometers. And it's a very sensitive system. Like you said, it's able to see these very small targets. It can see even smaller, and we tune it to just the right thresholds, if you will, to see those targets, and then we have a bunch of algorithms to filter out the clutter and other things that we don't want to see.
So from the operator standpoint, when he's looking at the screen, he's able to see from the screen and know the difference between a Boeing and a DJI Phantom?
So one of the nice things you'll be able to see as an operator are the size of different crafts, the velocities, and a DJI Phantom craft has a certain radar cross-section, if you will, versus a much larger aircraft. They may be flying at different velocities. So there's different ways to characterize those just from the radar. But then we also use a mixture of other sensor technologies and fuse those together to give you an even more intelligent picture of the airspace. We use something called spectrum sensing, which is basically like passive RF detection, where you can look for comms links and other signals coming off of the craft. So a DJI Phantom may have very unique signatures and comm signals that we can see coming off of there versus other things in the airspace like birds, hang gliders, or large aircraft, if you will.
So it can see birds as well?
Absolutely, yeah, and that's one of the challenges in this space. You could see a bird, a large bird, looking roughly the same from a radar perspective as a drone. They could potentially be flying the same speeds and have the same radar cross-section. Now, there are some characteristics of birds versus drones that there are out there. We try to work those into the algorithms, but it also helps to have other sensors that you can fuse into the picture. Birds usually don't have comm signals coming off of them. So if you get a radar hit, and then you also have spectrum sensing saying, hey, there's communications coming off of here, it's much more likelihood that that's a drone versus a bird. We also use optical sensors as well to give us verification of what's out there in the airspace as well. So the more sensor data we can put together, the higher degree of confidence we have in what we're looking at.
What type of users, or who are the potential clients for this technology?
We're really looking at the market space from Gryphon Sensors standpoint, two main buckets. One is UAS integration. So who are the people out there that have unmanned systems and they want to safely integrate them into the airspace, specifically beyond visual line of sight? One example, a program we're participating in right now is the Pathfinder program with BNSF, where the FAA is working with them on one of the first demonstrated use cases where they're allowing them to fly beyond visual line of sight. And BNSF is using drones to inspect rail track at a 100-mile stretch. And they're using our ground radar technology to characterize the airspace, look for any non-cooperators that are out there, and then they can say, hey, it's safe to fly here or it's not. And if there happens to be non-cooperators in the airspace, they have different procedures, but they may just have to land and wait until that airspace is clear. So that's an example of one user on the integration side, and you could think of a bunch of other use cases where people want to fly beyond visual line of sight, whether it's other inspection, ConOps, precision agriculture, potentially delivery, like we talked about, is a big one that most people are talking about. Search and rescue. There's many applications where people want to fly beyond visual line of sight, and we think we have some unique technology that can help them clear the airspace as safe before they make those flights. And this is something that the FAA is comfortable with, as evidenced by the Army's ground-based sense and avoid program and some of the early work that they're doing on the Pathfinder program now with ground radar. So that was the integration side of the market. The other side of the market that we're looking at and talking to a number of customers right now is more on the drone security side of the market. So you can think of a number of areas where people want to keep drones away or protect critical infrastructure, or maybe Fortune 500 companies that want to be able to know what's in their airspace. Maybe they're worried about IP potentially being videoed or captured. So those are a number of customers. And also we're a part of another FAA Pathfinder, which is on more of the security side. There's an FAA Pathfinder for characterizing drone security solutions around airports. So we're actually taking part in two FAA Pathfinders. One's on the UAS integration side and one's on the drone security side.
In terms of the equipment needs, what's it take to protect something like an airport?
Great question. One of the kind of starting points that we're looking at is trying to make sure we can at least give a surveillance picture out to 5 nautical miles, because that's an important requirement from the FAA side. So that's kind of the starting point we're looking at. But the nice thing with our system, which is called Skylight, it's a very flexible, scalable system, and you can plug in whatever number of sensors you need to cover a certain coverage volume. So some airports may say, hey, I really want to see out maybe further than 5 nautical miles, or maybe there's one approach corridor. We really want to focus on this one. Seems like there's a lot of drone incursions here, heavy traffic, and maybe we can hone in on that one corridor for them, maybe out beyond 5 nautical miles. So there's a lot of flexibility with systems that we have, but typically we'll come into a customer, try to understand their requirements, their ConOp, and then we'll customize a solution for them. And it could be multiple radars, multiple spectrum sensing nodes, and then maybe some optical cameras in certain areas where they really want to get identification on a potential threat that's there.
Are the systems on the market now or still in development?
We have systems that we're using right now that are camera, spectrum sensing, and radar, spectrum sensing, and camera. And the radar that we're utilizing right now is a legacy SRC radar called the SR Hawk. It's a very capable radar, but once again, it's more of a repurposed radar. It was a ground surveillance radar that has some low altitude air surveillance capability. It's a two-dimensional system. And the R1400 radar that we talked about that we've been developing for the last couple of years, that's coming online this fall. We're pretty excited about it. We have prototypes going up on the roof here at SRC and Gryphon Sensors here shortly, where we can track air targets and characterize the system. And first systems will be going out to the market in early 2017.
How about the operational side of the system? Do you come in and train an existing staff on how to manage the operation? Or do they contract with you and you manage a system for a fee?
It's a little bit of both, and we're trying to listen to the market there. It seems like the main pull from the market is more towards a service model, especially on the drone security side. Some of the companies we're speaking to, they don't want to add manpower. They don't want to necessarily have to train people. They just like you to be able to come in, deploy the equipment, offer it as a service to them. But there still are unique, sophisticated customers that really want to be trained up and then hands off to them. So we're looking at both models right now, but it seems like the market's asking more for the service-based model.
Is that something you can accommodate?
That was what we envisioned as well from the beginning, and the way we've been designing our skylight system. Everything is going to be phone home bit, if you will. So all sensors and systems we plan to be able to access at all times, to be able to monitor, optimize those systems, almost like Tesla cars. They're all basically plugged in back to Tesla once they're operational. We want basically the same model with our systems that are out there installed.
Walk me through the components of the system, because I know you have different types of radars or different levels of service depending on the need. So could you go through those again?
Yeah, so we look at it at our high level, it's our skylight system, and we think that it's the right approach to really give you your best chance to see anything that's in the airspace, because it's a multi-sensor, multi-spectral approach. We think we're really world leaders in radar, and with our R1400 radar, we think it's a real leading sensor there. So our base system there starts with ground radar, basically, and that's your broad, long-range surveillance to really be able to, see everything that's out there in the airspace. And then how do you begin to characterize with more levels of confidence what you have out there? And that's when we start adding in our spectrum sensing nodes, which is more our passive RF detection. So we can look and see signals that are coming off of craft and maybe off of ground controllers as well. And then we start adding that data on top of our radar data, and you start to have more correlation of what you're looking at out there. And then we also are adding in cameras for optical detection. So with your skylight system, you can imagine it's operational. There's a user sitting at the control station. There's a radar detection. There's spectrum sensing that's fused to that. High level of confidence, that's probably a drone. That person's then going to have a camera that slews to that target to help them identify, yes, it's a drone. And then maybe for a security application, they may say, what's that drone carrying? Much different reaction for certain security settings. Maybe you're in a stadium, and majority of the traffic out there that they detect for drones is probably just going to be hobbyist craft, looking to video something. And that may warrant a much different response than if they see a drone that looks like it's carrying a nefarious package, or maybe even something more deadly like some type of weaponization.
How sensitive is the camera? How far can it see to be able to really discern a drone from some of the other objects out there?
We have a wide range of different cameras that we use for different applications. Some people say, it's just driven by requirements of the customer. How far out do they want to be able to see? And there's identification, is there something there? And then there's classification and being able to, is it a bird or a drone? And then there's, being able to determine if it's carrying something. So, we work with the customers on what range is out. Do you want to be able to perform these different functions? And there's multi-million-dollar cameras that can see out to, 10 kilometers and beyond. Not really things that we're selling, but if there's a customer that came in and really wanted that, that's a potential option as well. But most of the cameras we're looking at are more in the 1 to 2 kilometer, 3 to kilometer range of detection that most customers seem like they're looking for.
Everything that we've been talking to thus far has all been about detecting a drone in the field. Are you working with any other companies on the next step of what happens once you have detected a drone? What happens next?
Yeah, so this is more on the security side. Yeah, I think what type of mitigation solutions are out there. Yes, we're talking with a number of potential partners on mitigation solutions. We think we bring something really unique to the market, being able to help people know exactly where these craft are, and then you could potentially hand off to some type of mitigation solution. Our parent company, SRC, does a lot of that work on the military side for counter UAS, and they have mitigation solutions, so we're very aware of what those are. We're being careful in the commercial market, especially in the U.S., because mitigation looks like it's not there yet. Some mitigation solutions are jamming, which is illegal right now. And then even just trying to interfere with a drone flying, the way the regulations are written right now, that's taking down an aircraft, the way they're written. So we're looking at a number of mitigation solutions out there and trying to understand when they can be brought to the commercial market.
If we could, let's talk a little more about the air integration piece.
Yeah.
You mentioned that you're working with NASA on their project to integrate drones into the airspace.
Yeah, their UTM initiative. So UAS Traffic Management is an initiative they've been leading for the last couple of years. They have 250 plus collaborators now. Dr. Paramal Kaparkar has been leading that effort, and he's really helped accelerate, move this industry along.
What's the role of Gryphon Sensors in that project?
So we're providing basically surveillance data, if you will. We're at the events that they've been conducting, and they're prepping right now for TCL2, Technical Capability Level 2 demonstration event this October. And we're providing basically surveillance data from our ground radars. So we're helping detect non-cooperative aircraft that are out in the airspace so they can get to the point where they can conduct beyond visual line of sight operations.
What do you see as some of the challenges in this air integration piece that we're going to need to resolve before it really is open to everyone?
I think there's a whole host. There's a lot of policy pieces that need to be worked out. There's public perception, making sure people are comfortable, with these type of craft being integrated into their daily lives, privacy, those types of concerns. From the technical side, like some of the work we're doing with BNSF right now, at the end of the day, the FAA is going to say whether or not you're allowed to do something in the airspace, and you have to work with them on a safety case and prove that your technology is safe. And that's what we're doing with BNSF, where they're starting to fly beyond visual line of sight, using ground radar to detect non-cooperatives that are out there. So there's basically the whole policy public perception side, and then there's validating technology side. I think the technology hurdle is much more showing the FAA, because there's a lot of capable solutions there now, and we're bringing new technology to the market as well. The FAA, to their credit, has been very receptive in wanting to work with the community and understanding what solutions are there. And basically, the message we've been getting from the FAA is we're looking for solutions. Just involve us from the beginning. Show us what kind of data you're collecting. Don't go out and run some operations and exercises for a couple of years and then come in, and then you don't have the data we were looking for. But they've been very cooperative and collaborative in bringing beyond visual line of sight solutions to the market. So I think there's technical challenges and policy challenges, and maybe the policy ones may be even bigger at this point.
What are the next steps for you and Gryphon Sensors? Where do you see the company spending most of its time and energy over the next several months?
We're spending a lot of time and energy, like we mentioned, on some of the Pathfinder programs, one on the integration, one on the security side. There's a program in New York State that we've been spending a lot of time on called Project USAFE, and that stands for UAS Secure Autonomous Flight Environment. And that's an initiative thanks to the governor of New York, where they've put $250 million behind Safe UAS Integration Initiative over the next 5 years, where we're going to be building out implementations of real-world UTM in the central New York area. We're also going to be doing work around critical infrastructure protection across the state of New York. So we're going to be spending a lot of our time there. And the end goal of that project is to hopefully get people into the airspace years sooner. We've partnered with the FAA and NASA to work on this project. FAA is helping us with, what kind of data, like we said again, what do we need to be collecting as part of the safety case. We're going to be validating a number of beyond visual line of sight use cases. And the end goal is at the end of 5 years to have a fully operational, beyond visual line of sight UAS traffic management infrastructure in central New York.
That's pretty cool.
It's a very exciting project. We'll be spending a lot of time there, and there's a number of industry collaboration partners domestically and also international partners that are taking part in this effort.
And lastly, what do you hope will be the impact Gryphon Sensors has ultimately on the drone industry?
We would like to feel like we've been a leader that's helped safely integrate UAS into the national airspace and help move that ball forward and really move the needle over the next couple of years. One other thing I did fail to mention there, Central New York's going to be hosting the UTM 2016 convention in November, where we'll be briefing out more material to the community on Project USAFE, and NASA will be briefing the results on Technical Capability Level 2 that they're working in October out to the community in November as well.
That's it for this InterDrone segment. I hope you enjoyed hearing from Craig Marcinkowski of Gryphon Sensors and hearing about their drone detection systems. I want to thank Craig for spending a few minutes with me at InterDrone. If you want more information on Gryphon Sensors, check out their webpage at gryphonsensors.com. Thanks for listening, and I hope you'll download other InterDrone segments, as well as the general Drone Radio Show podcast, to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.